Hello everyone, I'm Divya. Today I'm going to present on Artificial Bee Colony based Fisheye State Routing protocol. This is basically this dissemination technique. These are the following outlines. Firstly, we should know what is valid. Valid is regular aggregate method which provides a tangent transportation system. It mainly provides two types of communications, like vehicle-to-vehicle communication. This communication is between two vehicles, which we can see two roads. Vehicle-to-infrastructure communication is between vehicle and RSUs. RSU stands for roadside units. Advantages of WANET, right? WANET is so popular in marketing because it provides information sharing. You can share information using WANET because it is an intelligent transportation system, cooperative driving. Drivers can communicate with each other. Value-added service like navigation, internet access, etc. Basic components. Wireless access in vehicular environment, which is where dedicated short-range communication, which is DSRC. These two are the standard protocols of unit. Rainbow unit and roadside units are the components used in communication. Onboard unit is situated in the vehicle which provides communication. GPS is installed in OBU. Roadside units are the infrastructure located on the sides of the roads which provide communication. These are the literature surveys. After that objective, the main objective of this presentation is to study and explore the existing language standards for efficient data broadcasting, to design and implement an efficient broadcasting scheme for value capacity enhancement, testing and validation of proposed approach using standard or custom tools. Here the tools used are MS2, Move, Sumo, problem statement. The Fisheye State Routing is predefined protocol, which is already discovered. In Fisheye State Routing, there are various drawbacks. Poor performances, null ad-hoc network, do not have any information about distinct nodes, message overhead, redundancy in selecting names forward. But here we emphasize on two disadvantages or drawbacks, that is redundancy and massive overhead. After that, this is a scenario in which work is done. In Fisher state routing, firstly the region is divided into universal divided into regions. Then food source. Food source is here is node. Node is initialize, means where extreme occurs. Then neighboring list or topology table is calculated. Neighboring list means nodes which are one hop distance from that node is calculated. After that, we analyze the position of food source and go back to height and evaluate solution quality. Solution quality here is just density. Node having highest distance and highest density will be selected as the next forwarder. And look up visit best food source. Best food source means high density and high distance. Find the abandoned node which is already exists. Then terminate operation criteria. If satisfied, then exit. If not satisfied, then this process keep on repeating. Then this is the output list for FSR and home. Here, not first means this node is the forwarding node. It shows -2. -2 means next forwarding node. Here 1, 2, 3 represent regions. These are the distances, these are latitudes, these are longitudes, and this defines the region. This is the graph for next product 1. Here we can see that in region 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 nodes exist. And after that, the node having highest distance will be selected as next forwarder and The corresponding graph is here. But when we use ABCD Fisheye technique, here the nodes which are exist are considered to be abundant by using -1. And here only 1, 2, 3, 4, 5, 6, 7 nodes are expected from 15 to 7 nodes. It means message overhead has been reduced. Here we can show the comparison between our proposed technique and the Fisheye technique. This graph shows that when user is 1, this shows the number of nodes and this shows next forward. Here, in case first, how many nodes are selected? Around 11 or 12 nodes are selected as next forward. But here, only 2 or 3 nodes are selected. In second scenario, 15 nodes are selected, 15 nodes are selected. In third scenario, same nodes are selected. But in third case, there's a huge difference. We can say first, in first case, number of nodes this, then this, and then this. What's a contribution to society? Improvement in road safety is a strong academic emphasis and interest. A possible way to prevent mishappening is to use safety applications which extend information using wireless network. If something provides safety, that thing is very important to the main contribution to society is safety. It provides convenience, as I have told you, it provides navigation, GPS. So this you can find the way very easily. Fast message dissemination. After conclusion. The conclusion is on this that ABCP Fisheye State Routing Protocol for message dissemination and understanding is an efficient forwarding mechanism. As I have shown in the comparison, the proposed system focuses on the issues such as inaccuracy in choosing the forwarder and message overhead. After comparing the result of existing Fisheye State Routing and proposed technique proved to be more efficient. Now future scope. As I have told you, I have implemented the modified nodes. You can implement with more nodes like 200 nodes, or I have implemented using mapping. But we can show it dynamic, shorting with dynamic network like Sumo and by using Sumo or MS2 simulators. To use more parameters like we have used two parameters, distance and density, but here we can use speed, direction more for more accurate and efficient results. This is my application status. These are the references. Thank you.